Hey Vamsi, this is a great question about the 1vs1 classifier in scikit-learn. It's a technique used for multi-class classification, meaning we're trying to sort data into more than two categories, A, B, and C in this case. The question is asking us to understand how this classifier works under the hood. Option A suggests that only three individual binary classifiers are trained. Let's think about this. A binary classifier is one that distinguishes between only *2 classes. With 3 classes, we need to consider all the possible pairings. Is that really just 3? Option B gets to the heart of how 1vs1 classifier works. It correctly identifies the 3 binary classifiers needed, one for A versus B, one for A versus C, and one for B versus C. This covers all possible pairings of our 3 classes. This is absolutely true. Think about a single data point labeled A. It's used in the A versus B classifier and the A versus C classifier. Each point contributes to multiple binary comparisons. Yes, after training these 3 classifiers, each will make a prediction for a new data point. The final classification is a democracy, the class with the most votes wins. This majority vote approach is a core element of the 1vs1 classifier. This row simply lists the 3 pairs of classifiers trained by 1vs1 classifier. This clarifies the combinations explicitly. Okay, let's break down this majority vote concept. Remember, we have 3 binary classifiers, A versus B, A versus C, and B versus C. Each classifier makes a prediction, either A or B, A or C, or B or C. The majority vote simply means we count how many times each class, A, B, or C, was predicted by the classifiers. The class with the most votes wins. For example, if A versus B chooses A versus C chooses A, and B versus C chooses B, then A gets 2 votes and B gets 1 vote. So the final prediction is A. It's like a simple election. Okay, let's break down this majority vote concept. Remember, we have 3 binary classifiers, A versus B, A versus C, and B versus C. Each classifier makes a prediction, either A or B, A or C, or B or C. The majority vote simply means we count how many times each class, A, B, or C, was predicted by the classifiers. The class with the most votes wins. For example, if A versus B chooses A versus C chooses A, and B versus C chooses B, then A gets 2 votes and B gets 1 vote. So the final prediction is A. It's like a simple election. This is the final outcome. After the majority vote, based on which class received the most votes from the 3 binary classifiers, that class is predicted as the final classification for a given data point. It's the conclusive answer obtained by using the 1vs1 classifier model. This is the final outcome. After the majority vote, based on which class received the most votes from the 3 binary classifiers, that class is predicted as the final classification for a given data point. It's the conclusive answer obtained by using the 1vs1 classifier model. And that's it. The final prediction is made based on this majority voting system from the 3 binary classifiers. It summarizes the results from the pairwise comparisons. And that's it. The final prediction is made based on this majority voting system from the 3 binary classifiers. It summarizes the results from the pairwise comparisons. Okay, so we're dealing with a multi-class classification problem, meaning we have 3 distinct categories, A, B, and C. Think of it like sorting apples, bananas, and cherries into separate bins. Each data point represents a single fruit, and our goal is to correctly assign it to its corresponding category. 1vs1 classifier, as the name suggests, works by creating several binary classifiers. This means one classifier will compare only classes A and B, trying to determine if a data point is in A or A, B. This is like having a separate sorter that only compares apples and bananas. Another binary classifier compares classes A and C. This one focuses solely on distinguishing between A and C, or in our fruit analogy, between apples and cherries. Finally, A third classifier distinguishes between classes B and C, bananas versus cherries. After each of the three classifiers makes its prediction on a data point, a majority vote decides the final category. Imagine each classifier casting a vote for either A, B, or C. The class with the most votes wins. The final prediction is simply the result of that majority vote. If two classifiers vote for A and one for B, the algorithm assigns the data point to category A. This is our final classification decision. Okay, let's break down the ONVSONECLASSIFIER architecture. Imagine we have three classes, A, B, and C. This clever classifier doesn't try to tackle all three classes at once. Instead, it creates separate, simpler battles, or binary classifiers, that compare each class against every other class. It's like having a series of one-on-one matchups to determine the overall winner. Think of it as a round-robin tournament. We have our data points, each belonging to one of the three classes, A, B, or C. This is the data our classifiers will use to learn and make predictions. This classifier focuses solely on distinguishing between Class A and Class B. It learns the features that best separate these two groups. It's a simplified problem, compared to sorting all three classes simultaneously. Similar to the first one, but now this classifier is trained to differentiate between Class A and Class C. It learns the unique features that separate these two classes. This classifier tackles the final pairwise comparison, Class B versus Class C again. It focuses on learning the distinguishing features for these two classes. Once each of the three binary classifiers has made its prediction for a new data point, we use a simple voting system. Each classifier casts a vote for one of the two classes it was trained to distinguish. The class with the most votes wins. The class that receives the majority of votes from the three binary classifiers is declared the final prediction for the new data point. So, it's a democratic decision-making process among our classifiers. Okay, so we're using ONVSONECLASSIFIER from scikit-learn. This is a clever way to handle multi-class problems, like classifying things into more than two categories, using several smaller, simpler, two-class problems. Think of it like building a system to sort different types of fruits, apples, bananas, and oranges. Instead of building one big machine to sort them all, we build three smaller machines. One for apples versus bananas, one for apples versus oranges, and one for bananas versus oranges. We have three categories of data, A, B, and C. Think of these like the three types of fruits from before. This is the starting point of our classification task. We want our model to learn to distinguish between A, B, and C. After each of our smaller classifiers makes its prediction, we use a simple voting system to get the final answer. Each of the three classifiers votes for either A, B, or C. Whichever category gets the most votes wins. It's like a democratic decision-making process amongst our three mini-classifiers. Majority rules. This is the final output of the whole process, the classification of a new piece of data, based on the majority votes of our three smaller classifiers. It's the answer to the question, what category does this new data point belong to? Okay, let's break down the OneVsOneClassifier training process. Imagine we have three classes, A, B, and C. OneVsOneClassifier doesn't train one big model. Instead, it cleverly creates binary classifiers for of classes. It's like a series of one-on-one battles. The first classifier will focus solely on distinguishing between Class A and Class B. It learns the differences between these two, ignoring Class C completely for this particular model. Next, a second classifier is trained, this time pitting Class A against Class C. Again, Class B is ignored. It's all about A versus C. Finally, the third classifier focuses on the contrast between classes B and C, so you see, each classifier handles only a specific two-class comparison. It's like having three specialized experts, each solving a small, manageable problem. After training these three binary classifiers, we have our prediction panel of experts. When presented with a new data point, each classifier casts its vote for the class it thinks is correct. The class that receives the majority of votes wins, declaring that as the final prediction. This is the magic of the majority vote mechanism. Pretty clever, huh?